So order, yeah. Now we look at the order in our data. Yeah. So the question, yeah. So here, this line, an order must be defined if we use the greater than, less than comparison operators. Yeah. Some of you may ask, yeah, because based on our experience, we may feel for any data type, an order could be defined, right? Yeah, string, alphabetic order, numeric value, no problem. Date, yeah. The date, yeah. Next slide we will look at the date, time. We can define an appropriate order. Yeah. Yeah. But actually, sometimes you may not be able to define an order. That's possible. That, although the case is very rare, but it could happen. You don't know how to define an order. Can you imagine that? Can you imagine that? For a certain type of data, nobody knows how to define an order. Think about that. Yeah. Okay? Yeah? So here, I want to mention this point. For certain types of data, no order could be defined. Although this case is rare, but possible. Okay? Yeah. So let me give you an example here. Yeah. Remember, we learned multimedia data before, right? Remember? We can store multimedia data in our database. Yeah. Let's look at the multimedia data. And the multimedia data, we know this binary data, right? Yeah. Binary data. Binary data, audio file, image files, and video files, all binary format. Okay? Yeah. But we can store, so the DBMS allows us to store the binary multimedia files, content in our databases. Yeah. Remember the data type I mentioned before. So the data type for the multimedia data, we use blobs. Blob, okay? The data type is called B. L-O-B. That's the data type, blob. So what's that? Yeah. Binary, the first B, binary, large object, OB object. So binary large object. Yeah, that's the data type. The content is binary content. Yeah, all right? Yeah. So you can imagine the binary content. Okay? Yeah. So think about how to define an order. Okay? Nobody can define an order for this type of data, right? Yeah. You know? Yeah. So no order can be defined. Yeah. Then you cannot do comparison using greater than sign, less than sign. You don't know. So, yeah. So then the possibility. So that's why, yeah. Although it's rare, yeah. So most of the time, so we don't worry about the order, but because The order could be defined. Yeah, but there is a possibility. Okay, so the no order is defined, but we can apply equal sign comparison, right? No problem, because when we apply the equal operator to compare two pieces of data, we do not need order. We only match bit by bit if the content of two pieces are exactly the same. Then the comparison can be done. Yeah. Okay? Yeah. So that's the, special case. Yeah. All right. Then compare values for individual data types. Yeah. So a few more cases. Numerical data, yeah, so we're familiar with. Natural order, yeah. Character string data using the alphabetic order, yeah. Compared, yeah. And this line, actually, last time I used one example explained. So here I do not need to repeat it. So when a string value happens to be a number, yeah, double quotes, okay, string, we use double quotes or single quote, yeah. So here, there is a double quotes, single quotes way. Yeah, I will explain this. So string regarding string data. Yeah. In double quotes. Another way in single quotes. Okay, yeah. I will explain later soon. Yeah. So string value happens to be a number, double quotes 1, 2, 3, for example. Yeah. Because when we use double quotes, it must be string data. Yeah. It cannot be integer data. Integer data you should never use double quotes. Okay. Yeah. Numerical data you never use double quotes. Yeah. Okay? No quotes. No quotes. Numerical data, always no quotes. Okay? Yeah. All right. So the string data, yeah. But the content inside happens to be a number. Do not get confused with these two orders. Yeah? Because alphabetic order, you compare character by character. Yeah. That's different from the numerical value comparison. The example I used last time, so I do not repeat that. All right. Then date and the time data type comparison. We need to define order. Yeah, that's easy. Yeah. So let's look at how to define order. For a less than comparison, yeah, an earlier date is considered to be smaller than a later date. Yeah. Smaller than the later date. That's the definition of order. Earlier, yeah, the value is smaller. Yeah. That's the definition. Okay? Yeah. Smaller, yeah, because following the time axis, you have time axis, right? Yeah. Time flows, time axis. The value becomes larger and larger. Okay? Yeah. That order, that's the order. Okay? Natural date order. Yeah. And for the time, we also use this. Yeah. Earlier time means smaller time value. Yeah. And so on. Yeah, so that's the easy definition. Yeah. All right. Yeah. Then we have another data type called daytime data type, right? Yeah, combined date. Yeah, we can use this definition. Yeah, because we put a date first, then time after date part. Then we should compare the date part first, right? Only when the date part are the same, then we need to compare the time part. Yeah, so also very easy, we can define the order for this type of data. Yeah. All right. Yeah. properties for values of character, string, data types. Yeah. A literal string value. Yeah. So inside, I haven't explained one important thing. Yeah. So before I talk about this slide, remember, I haven't explained the difference, right? Yeah. First, both ways acceptable by DBMS. Okay? Both ways acceptable by DBMS. Yeah. But they're slightly different. Slightly different. Yeah. Single quotes way is the SQL standard, SQL standard. In SQL standard, it is the single quotes, not double quotes. Double quote way does not belong to the SQL standard. Yeah. But because the double quotes, people in our usual programming languages, we frequently use double quotes to represent string, right? Yeah. So most people like to use the double quotes way to represent strings. So then DBMS accept it. Yeah. DBMS does not reject it, so accept it. But after data is entered, DBMS converted to single quotes. Yeah. That's the conversion. Yeah. Simple conversion. Yeah. Does not reject it. Yeah. Because too many people do that. Yeah. Yeah. So don't do rejection. Yeah. Yeah. All right. Yeah. So that's the difference. Okay. Yeah, that's the difference. All right. Net properties. A literal string value. Yeah. So the inside quotes. Yeah. So literal string value. Yeah. All right. Case sensitive. Yeah. So for the string data values, case sensitive. Yeah. For the keywords, not case sensitive, right? Keywords, SQL keywords, uppercase, lowercase, same thing. Yeah. Yeah. Just the convention. Yeah. By convention, people, most of the keywords use uppercase, but small number of keywords still use lowercase. Yeah. All right. So placed between single quotation marks, apostrophes, that's the SQL standard. Okay? Yeah. Yeah. So this property, based on the SQL standard. Yeah. So the literal string values should be placed in a pair of single quotes. Then for fixed length strings, remember, sometimes we may, in a rare case, rare situation, people may use fixed length strings. Each data item must use certain number of characters. But your concrete data piece may not have that many characters. Last time I mentioned a little bit. Here, let me repeat that again. So the way to resolve that problem, padded with blank characters to the right for that shorter string. Not left. Yeah. So last time I used the example, if 6 characters, if our data type requires 6 characters for some business reasons, okay? Yeah, for some, business reasons. But the specific data entered only has 4 characters. Yeah. To make it fit into the data type requirement, pack 2 space characters. To the right, not the left. Yeah. Yeah. So the reason is simple. So why we pack it to the right, not the left? Yeah. The reason, pretty straightforward. Yeah. Because if you look at when we do comparisons, when we do alphabetic order, using alphabetic order to do comparisons, we start from the leftmost character, right? Yeah. First, second, third, and the fourth. Yeah. So when you pack space character to the right, you make the minimum impact, right? Minimum impact, yeah? Because you do not change the first few. You do not change the order for the first few characters. So you make the impact, yeah, you have some impact, okay? But the impact, if you put it right, the impact, you make it minimum, okay? On the other hand, if you pack to the left, then the impact is huge. Because when you compare the blank character first, okay? Yeah, second. So that suddenly you change the order big time, right? Yeah, significantly. Yeah. That's not good, right? Yeah. So based on that idea, here you can see certain rules are set. Yeah. Try to, for some specific purpose. Yeah. Yeah. Some reason behind it. Yeah. All right. For comparison purposes, strings are considered all. Yeah. So we discussed this a lot. Okay. Yeah. People also call it dictionary order. Yeah. Because when you look up words in a dictionary, you use this way. Yeah. There is also concatenation operator. Yeah. In SQL, the concatenation operator is quite different from the way we use in programming languages. Okay, C++, Java, JavaScript, plus sign, right? String concatenation. But in SQL, because SQL is much older than those programming language, older than Java, but may not be older than C++. Yeah. So the concatenation operator. Yeah. So do not get confused. Yeah. So the rules in SQL quite different. All right. So that's the part B. Yeah. So that's our part B. Okay. Yeah, we complete. Yeah. All right. Yeah. Next, we need to jump to part C. Yeah. Okay. All right. Oh, there is another thing before we jump to part C. Another thing, because regarding numerical values and string values, at this point, let me just mention that. Numeric values and string values. All right, yeah. We know numerical values when we represent no quotes, right? No quotes. With quotes. Okay, single or double, but with quotes. All right, yeah. But there is a situation. These two ways could be mixed. There is a mixed situation. So let me explain that mixed situation. Yeah. mixed for numerical values, not for string. String never mixed. Okay, string values always in quotes. But numerical values, there is a mixed case. Mixed case in PHP. Okay, when we use it in PHP programming, so what's that? Because in our PHP programming, when we do insertion, sometimes we need to insert numeric values. Sometimes we need to insert string values. And when we write out our code, people want to write the code efficiently. Okay? People want to write code efficiently in PHP. But think about your insertion code. So you have an insertion statement. Your insertion statement, how do you make your insertion statement? For this numerical value, so your insertion statement, when you insert numerical values, so you do not need to use quotes. When you use string values, you must use quotes, right? All right. But when you think about, so in your PHP, because in your you write a value, okay? So your data inside quotes. Then the value part, you use the PHP variable, okay? PHP variable start with $, okay? $, then variable name, var. See? What is that? var. Okay, double quotes, okay? So that's the value. All right. So you do insertion. If this variable, okay, in your statement, because in your insertion you have multiple pieces, right? So variable 1, variable 2, okay, variable 3, because you have several variables, pieces you want to the insertion, okay. These variables, some of them, part of them, string values, part of them, numerical values. Okay? If you want separate, too complicated, right? Some of the numerical values, some of the string value. If you separate them, very complicated. So the simple way, you put all of them in quotes, in double quotes. Okay? Then do insertion. Then, even some of the numerical values, when you do insertion, the DBMS accepts it. Okay. It does not reject it. Because your table definition, the DBMS knows this piece is supposed to be numerical values. So it will use the right data type. It does not use the string type. Because your table definition tells DBMS this is a numerical piece. Although it's inside quotes, but still inserted as the numerical value. So don't worry. So in the programming, if you put the quotes around numerical values, legal, no problem. Okay? So acceptable. It's convenient. For programmers, you do not need to separate, so it's convenient. Okay? If you separate, the logic could be complicated, right? You need to do a lot of checking things. Too complicated. So, don't do it. So that's something just, special, but in PHP. All right. Now let's get out. What's that? Yeah. Ooh. Part C. Yeah. All right. Concepts for SQL tables. Yeah. Yeah. Now we need to understand the table more. SQL table more. Okay. C.1, create a table. Yeah. So we saw before the command, create table statement. All right. Inside the statement, we need to specify. First, we need to give a table name. So then attributes, a list of attributes. Okay, columns, fields. The format for each attribute. So here, the format for each attribute. Attribute name first, comma. Then the data type of this attribute. Then you may put some constraint, some simple constraint. So the constraint after the data type, usually the simplest constraints. If the relatively complex constraint, you cannot, because too complicated. So you will put at the end. After you define the table, then you add constraints. Add constraints. Or at the end of table, you add constraints. Just later. So the constraint you will see, remember, not null. So some simple constraint. Okay. You will see a few constraints. Like unique. Unique is a constraint. Okay. Not null. Constraint. All right. Constraints. Let's look at the constraint. Key constraint, uniqueness. Key, we know the values must be unique. The value for this attribute, this column, must be unique. So that we call this column key column. Okay, then the value must have the uniqueness property. All right. Then entity integrity. So entity integrity constraint. So what's that? All right. So here we are talking about primary key. Primary key. All right. This primary concept. It must be key, but more than a key. Key uniqueness. So the primary key also has this uniqueness property, but more than that, some more properties. First, value cannot be null. No primary key value can be null. Because null means uncertain, right? Null means uncertain. So first, let me tell you. So what's the reason using primary key in a table? What's the reason using primary key? Identify. Identify the rows. Okay? That's the main purpose. Identify the rows. If you allow null value, you cannot identify the rows, right? So null value is not allowed. All right. Even if, not null is a constraint, but for primary key, you do not need to, because for primary key, this is a hidden, this constraint is not null is hidden. You do not need to say it, okay? You only need to declare this is a primary key, okay? So you can put a primary key keywords here, primary key keywords here. Then you tell DBMS this is a primary key. Okay. So we have several ways we can declare primary key for this field, this column. Right. But you do not need to, it implies, it must be, not null implies that. Unique and not null. Yeah. All right. Then another constraint called the referential integrity, foreign key. Yeah. Yeah. And some column you may want to use it as a foreign key. Yeah. Yeah, foreign key. This concept, we need to use one whole topic to explain foreign key. Yeah, here we just mentioned there is a foreign key. Yeah. Foreign key, if you only tell the DBMS, so this attribute you want to use as a foreign key, that's not enough. Because foreign key, you need to refer it to some key of another table. There is a referencing information. You need to specify the referencing information related to another table to complete the foreign key definition. So you need to do more on foreign key. Yeah. So we delayed that topic because it's a little more complicated. Yeah. Here you just know there is this kind of thing. All right, referential integrity, foreign key. Then, this alternate way to add constraint, yeah. That is, we do not, because if the constraint relatively complicated, we do not need to do here. We can do later. Later, how do we define the constraints later? Later means after we complete the definition of tables. We can delay after the table is defined later. And this way, actually this way is very useful and very powerful. We can do a lot more things. Yeah. So this is a, good option. Yeah. Good option. Yeah. Yeah. So we will see that soon. Yeah. Especially for foreign key case, then this way is desirable. It's better. Yeah. Foreign key. Yeah. So this case has its advantage. Yeah. All right. Yeah. So how to do it after the table is created? Use another statement. That's this statement called alter table statement. You can modify the table. Alter table. Okay? This statement allows you to modify, change part of the definition in your table. Alter table. After that, you specify how to change. Yeah. Yeah. So, and this way, you can change a lot of things, yeah. including the foreign key. Yeah. Define foreign key. Yeah. Primary key, you can use this way. Yeah. Many things you can use this way. Yeah. Yeah. All right. All right. Yeah. Employee table example, employee table of company. Yeah. I just uploaded 2 databases under the module 3. I create a databases title. Yeah. Under that databases title, I uploaded 2 databases. One company, this one company, another Northwind. Okay, Northwind, the W3 School, Microsoft Northwind. So if you want to install a copy on your own machine, yeah, that's convenient. Okay, yeah. And as I said before, when you install on your own machine, yeah, because your exam software bundle, you use the most recent MySQL version. Yeah. And the W3 School used older version. Yeah. W3 School used the MySQL version 5. Yeah. In our exam, we use MySQL version 8. 8 and 5. So there is an important feature available in version 8, not available in version 5. Yeah. Later we need to use that feature. Yeah. In our complex queries, we need to use that feature. But when you do experiments in W3 scope, it's not supported. Okay? Yeah. If you want to do testing, you need to use your own version for testing. Yeah. Yeah, but that's the module 4. In module 4, we will get there. Yeah. All right. Example here. Let's look at the definition of employee table. This is definition. Okay. Yeah. So you have all these fields, yeah. And yeah. So here, let me explain. Yeah. Several things. I think. Yeah. First line. Yeah. All right. First, let me explain the first line. Okay. Why you add this one? Yeah. Job table if it exists. Yeah. So this table. Yeah. This table when I run, remember in the PHP my admin. I can import and export, right? Yeah, yeah, yeah. Export a database. Yeah. Suppose import, we know import, okay? Yeah. So we have database script. We import database script, so we install the database. Yeah. All right? So then we work. So we work on this database. Yeah. We change data, a lot of data. Okay, all right. Yeah. And we can change the definition of the tables, right? Yeah. When we work, we can change a lot of things, including definition. Yeah. All right. But after you make a lot of change, how do you get your current database in a database script? Export. The simplest way, you export this current database. Okay, so then, PHP My Admin has an automatic tool to generate the script SQL statements in the script. Yeah. All right. When it generates the SQL statements, it added the first line automatically. Okay? For each table, it adds this line. Yeah? So the generator added okay? Job table if it exists. Yeah. Yeah. In your original table, you may not have that line. Okay? But the automatic generating tool, it will add this line. Yeah, because that tool feels this way is better. Yeah. Yeah. How do we use this? Yeah. Because think about, when you work on a database, sometimes you need to change this table, right? Yeah. Sometimes you feel, oh, I need to add a row, or I need to change, some parts. I need to make some change. Yeah, that happens. In the database design, it happens. You may change the table. Right? After you change the definition of your table, how do you update it? What is the easiest way to update it? Think about. What is easiest? If you change several places. If you go there, change piece by piece, that's not efficient, right? Although you can do that. You make multiple changes. Now you want to replace the old version by the new version. What is the fastest way? The fastest way is you drop the old table. Drop it. Then you execute this create statement of the new table to replace it. That's faster, right? So drop first, then replace it. Yeah, that's the fastest change. Fastest way to change your table definition. Okay? All right. So now you can see this first line is useful. Drop table if it exists. Yeah? If it does not exist, don't drop, right? So DBMS, if it does not exist, right, you just run this create table statement. If it exists, drop it first. Then you replace it. Because if it exists, you do not drop, the DBMS will reject it. No, because the error message is the table already exists. You get that error. Table already exists. No. So you need to drop it first. No. So then the auto-generating tool added this line. So for your convenience, because you can replace the old table easily. Okay? When you replace, you copy this definition. Copy paste, including the drop line. You can replace old table easily. Yeah. So that's the first line. Why we use the first line? Yeah. All right. Then create table if not exists. Yeah. This is also used to avoid that error. Yeah. Because if the table already exists, you run this statement, you get error, right? Yeah. So this one, try to avoid that error. If it not exists, then you can run this. If it exists, do nothing. Okay? If it exists, do not run. Yeah. So another way to protect, see, another way to reduce the error messages from the DBMS. Okay, see? Yeah. So there. Yeah. So the constraint part, yeah, other parts you can understand easily. Yeah. Yeah. Yeah, but the constraint part, so not null, one. Default value, null, yeah. Default value. So if it's not provided, use the null value as the default value. Yeah. Yeah. All right. Yeah. Yeah. All right. Yeah. Yeah. Then the engine. Yeah. So there are several engines used. Yeah. So each engine has its own some specific meaning. So for us, we do not need to know that much details. Yeah. If you really need, yeah, then you can study the document. Yeah. So here usually, yeah. So we just take it. Yeah. All right. Yeah. All right. Yeah. So that's the typical definition. Yeah. And floating point. Yeah. Remember last time? Yeah. We learned the total number of digits before decimal point, after decimal point, adding together 10. But after decimal point, 2 positions after decimal point. Yeah. All right. Yeah. Another thing, remember the backtick, all these backtick used to, get around possible keywords, right? Yeah. Yeah. Even if some other fields happen to be the SQL keywords, yeah, because you put inside a pair of backticks, still, well, DBMS will interpret them as the literal name string, so not the keyword meaning. So the literal meaning. Yeah. Yeah. All right. Then alter. Yeah. So this alter statement generated by the auto-generating tool. Yeah. So and it defines the primary key using this alter statement. Yeah. Alter table name employee add primary key. Yeah. So this constraint is keyword primary key keywords. Yeah. Add primary key, yeah, parenthesis, then the field name. So this field is used as the primary key. Okay? Yeah. But this is this alter way, but many people like to put the definition of the primary key inside the original definition of the table. Now, later we will look at that. Yeah. So we will get to the primary key part a little more, yeah, because there are some special cases we need to consider for the primary key. Yeah. 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 All right. Yeah. So that's the example. Another example, department, also in our company database. Yeah. So the department, yeah, I think for the table definition, easy to understand. Yeah. Then let's look at the alter table statement. Yeah. Add a primary key, D number, department number, D number. Yeah. And so here, alter, we add a primary key, also add unique key, D name. Yeah. So the department name must take unique values. Yeah. So we use this way. Yeah. All right. Yeah. Add unique key. Yeah. D name. Yeah. All right. Yeah. 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 Oh. Yeah. Oh. Yeah. Okay. Then, base relations and virtual relations. Yeah. Yeah. Base table, virtual table. Yeah. We learned in our module 1. Yeah. Base table, physical table, right? Yeah. Virtual table, the views. Yeah. All right. So base relations, base tables. Yeah. Base table, well, when we declare, we use create table statement. Yeah. Yeah. All right. Relation and its tuples are actually created, stored as a file in physical file. Okay, as a file. Yeah, yeah. File would mean physical file by DBMS. Yeah. All right. The virtual relations we call views. Yeah. In our database context, we call the views. Yeah. So the create, we use the create view statement. Yeah. So we just replace table by view keyword. Yeah. The remaining part all the same. The remaining part, we just use the table. Same way we use in our table definition. Yeah. But you know, this is a virtual table. That means the data, because this view represented in this view, you can see it, okay? Yeah. You can display the data in the view, but it won't be stored physically on your hard drive. It won't be stored physically on the hard drive to save space. Okay? Yeah. But in the display, it looks like a table. Yeah. Same format of a table format, but no physical data associated to these virtual tables. Yeah. But what's the benefit? Yeah. Think about it. Let's recall. We learned before, okay? This view concept. Yeah. The benefit, we can save storage space. Yeah. You can imagine the situation why people use views. Yeah. We want to maintain relatively small number of tables, but we want to support large number of users. All those users, they have different requirements on your data. Yeah. So each group of users, they have their own data format they want. Yeah. So we define those views for different groups of users, large number of groups of users. We can provide services to all those users. But we do not need to use a lot of space to store the concrete data, physical data for those views, right? Yeah. Too much. Okay? Yeah. So we can save a lot of storage space. But we can provide the same services required by the users. Yeah. But for some special situations, yeah, we feel there is some good reasons. Yeah, we have options. We have options to store the view data, the data inside these views, virtual table views, physically on a hard drive. If we really need it, we can do it. Okay? Yeah. Okay. Yeah. All right. Yeah. So that's the reason we use the virtual tables. Yeah. It may or may not correspond to actual physical file. Okay? So most of the time, not. Okay? Only for some special situation, yeah, when people have good reasons, then do it. Yeah. Store the physical file. The reason for physical file, think about the situation, the reason, good reason to use physical data for views. Yeah. Imagine the situation. Because when we use views, every time when we need to display the data in these views, we need to run SQL statement to generate the data, right? Yeah. We need to generate the data, yeah, for the views. And the generating data, it may take some time, right? It takes some time. Every time we need to run, let's say, a sequence of SQL statements to generate one particular view. It may take some time. Yeah. If the time needed relatively long, then the users may need to wait some time. The response time relatively slow. If we do not want our user waiting too long, then let's store the data physically. Then next time we do not need to generate. Yeah, because we have the physical data. Right? Let's just use our physical data immediately. So then you skip the generating process, right? You skip relatively long generating process. That's the reason. Yeah. So people sometimes they need to use the physical storage of the view data. Yeah. If it's very fast to generate the view data, then no need. Okay? Yeah. So you just use the virtual data. Yeah. Contain the derived data. Yeah. Yeah. Yeah, because we treat all the data in the views as derived data. They are not original data. Yeah? Not original data. Yeah. So if you derive the data, if you remove them, yeah, you have no loss in your original data. Yeah. So derive the data. All right. C.2, order property. Ordered or not for attributes and tuples. Yeah. Here, this order, yeah, in this C.2, we want to understand orders in these two. Yeah. One is the inside attributes. Another is in a list of tuples. Yeah. The order requirement is different in these two cases. Yeah, let me explain. Yeah. Yeah. Do not get confused. Yeah. All right. In attributes column, a list of columns. Yeah. When we do the query, when we retrieve the data from our tables, we need to specify your data for what columns, right? You need to give a list of columns when you retrieve your data. Yeah. All right. Then you have order there, right? When you list several columns, there is order there, right? Yeah. First name, last name, age, birth date. Yeah. So there is order. Yeah. So we need to consider order when we list the attributes. The attributes in a base table, you know the meaning? The physical table. Base table, yeah, table, okay, are considered to be ordered in the sequence that are specified in the create table statement. Create table, when you create table, you need to provide a list of attributes, right? Yeah. So that order matters. That order matters, okay? Yeah. The first one, second one, third one, that order, you need to follow that order. Yeah. Yeah. Okay? Yeah. Why that order matters? Why order matters? Yeah. If you use Java, JDBC, yeah, the Java, the database technology, the base level, not the higher level. Higher level, there are many higher level, okay? Hibernate, several. Yeah. But the base level is the JDBC technology, Java database connectivity. Yeah. In the base level, JDBC, yeah, there is a statement. Yeah. So when you access columns in your table, there is one version using first column, second column, third column. You use the parameter 1, 2, 3 to access your columns. Then you have to follow the original order, right? So which one is the first? Which one is second? You need to look at your table definition. Yeah. So the first one lists there, oh, that's the first. That's second. Yeah. You need to follow the original order. Yeah. So order matters, okay? Yeah. In the attributes, the order matters. Yeah. Yeah. All right. In tuples, in rows, yeah, that's a different story. Yeah. When we have a list of, here, let me draw a diagram. Yeah. So when we talk about rows or tuples, so when you retrieve the data in a table, you have row by row, right? Yeah. Row 1, row 2, row 3. You have a list of rows, R1, R2, and so on. Okay? Yeah. List of rows. Yeah. Then there is order, right? Yeah. Yeah, because you can change the orders. Yeah. There is order there. Yeah. Which is the first row, second row, and so on. Yeah. There is order. Okay? Yeah. So what is the rule for the order in a list of rows? When you retrieve the data from a table, the rule is different. Let's look at the rows. The tuples are not considered to be ordered, okay? Within a relation, within a table, okay? So that means if you change R2 and R3, yeah, R1, R3, R2, we treat as the same table. You do not get a different table, okay? Yeah. If all the rows are the same, but in different order, you still have the same table, okay? Yeah. You just change the order without changing the content of those rows. You do not change the table, okay? You have the same table. That is the understanding of the order in a table. Different from the attributes. Attribute, when you change, it's different. Yeah, that's quite different, okay? Yeah. But here, same. Yeah. All right. Understanding, yeah. elements inside a tuple are ordered. Yeah. So here, because sometimes students messed up regarding the order. Some students mess up. You talk about order with respect to tuples not important. Yeah, here, yeah, because based on this, not consider the order not important. But they messed up, yeah, because each row. Look at each row. Each row, you have multiple elements, right? You have multiple elements inside each tuple. That order is important. Okay, that order you cannot change. Yeah, within each tuple, the order matters. Order matters. You cannot change. Okay, yeah. But if you treat each tuple as an element, that order doesn't matter. Okay, you treat one tuple, the whole thing, as one element, then you make change, doesn't matter. Okay? But when you get into the tuple, you change the elements inside one tuple, yeah, the order matters. Yeah. When you change, you get a different tuple. Yeah. So that's the understanding. Yeah. So many students get confused. Yeah. So they understand whenever you talk about tuple, the order doesn't matter. Yeah. But inside, it matters. Okay? So they get confused like that. Yeah. All right. Yeah. When we treat the tuples as elements, they are unordered. Yeah. One tuple is one element. In that situation, yeah, unordered. Yeah. We view a relation as a set of tuples. Yeah. Yeah. Here, when you use the word, be careful. Set of tuples. Remember, last time when I talked about this set concept, I mentioned another closely related concept called multiset, right? Yeah. I mentioned another called multiset. Oh, sorry. Oops. Quite annoying. Multiset. Horrible. Yeah. 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 Actually, this multiset word is better than the set. Yeah. Because set, people can easily get confused. What's the meaning of set? Okay. Is it a mathematical set or our daily life set? Our daily life set could be different from math set, right? Yeah. Math set, there are some requirements, yeah, we need to follow. Yeah. So here, yeah, multiset, we know duplicate rows are allowed. Set, if you understand as the mathematical set, duplicate rows are not allowed. Okay? Duplicate rows are not allowed. Yeah. Yeah. But when we talk about table, in business, table, duplicate rows are allowed. Okay? Yeah. So yeah. That's the difference, the multi-set, set. Okay? Yeah. So when you see the set word, you should be very careful. Okay? Yeah. Very careful. Yeah, set or multi-set. Yeah. Difference. Formal relational model. Yeah. So here, we know formal relational model. That's the, academic project. In academic project, it does not use multi-set concept. Yeah, because those researchers, they use their logic to design the project. Okay. Yeah. They may not have the real world business experience. Those researchers in academia, so they use their, intuition, logic, to design the structure of the project. So they do not feel the need to allow duplicate rows. Oh, unique rows. That's perfect. But the business people, in their applications, they feel they really need to allow duplicate rows. Yeah. So that's why they make the change. Yeah. SQL emphasizes on real-world applications. Yeah. The formal relational model emphasizes on rigorous theory. Yeah. Rigor of the theory. Okay? Yeah. Yeah. So because they want to make the theory look beautiful. Okay? No holes. Yeah. Perfect. The structure-wise, perfect. Yeah. But may not be practical. Yeah. So you put a lot of restrictions, but that means you put a lot of limitations to the business people. Right? Yeah. Too much restrictions. Yeah. Yeah. Too many. Yeah. All right. Yeah. Yeah. So the views of tables or relations. SQL allows a table to have two or more tuples that are identical in all their attribute values. So a table is a multiset. So in business, what is a table? Table is a multiset in business. Yeah. Yeah. Set is only a special case. So the general, when we talk about general table, it must be a multiset. Yeah. All right? Yeah. Okay. Oh, at this point, let me ask you one question. One, to check your understanding. Yeah. So we have a table. Okay? We define a table. And I also tell you, this table contains a column that is a key column. This table contains a key column. Okay? You know the meaning of key, right? Key column. Unique values. All the rows with respect to this particular column, the values must be unique. That's the key column. Okay. Now I ask you, a table with a key column, is it a set or multiset? Set or multiset? Based on our understanding of these two concepts. A table with a key column, set or multiset? Multiset, you need to consider two or more tuples identical in all their attributes or fields. Yeah. Attribute values must be identical. But when you have a key column, with respect to that column, can you have two rows with identical values? Unique, because there is a unique requirement, right? Based on the unique requirement, any two rows for that key column, the value cannot be the same, right? If the same, rejection. DBMS, because DBMS does not allow it. Then you can only have a set. You cannot have multiset, right? You cannot have multiset. See? Yeah. So a table with a key column, you can never get a multiset. Think about that, right? Check your understanding. Okay? Yeah. So you need to. Yeah. So you need to put multiple pieces of knowledge together. Okay? Yeah. So key property, set, multiset, set properties put together to make your conclusion. Okay? Yeah. All right. So let's stop right here. I need just one or two slides. I can complete part C. Yeah. So, remind you again. So today Thursday. So tomorrow. Let me try to do tomorrow. One is the quiz number 3. I will post quiz number 3 first. Yeah. So you will see quiz number 3 first. After that, I will post, let's say this way. Quiz number 3 appears on Friday, and homework number 2 appears on Saturday. Okay? Yeah. So, yeah. As before, yeah. After that, we need to prepare for the midterm. Okay? Yeah. After these 2 assignments, then that's our midterm time. Okay? We need to review, then we do midterm. Okay? Yeah. So another week. So this week. So we finish this week. So next week. Okay. Then another week. Then midterm. All right. Yeah. The last week of the October. Last week of October.